Welcome to Study Loop.
So, while traveling through the electric field, the electron follows a projectile path like so, with x naught and y naught as the initial position of the electron and xf, yf as the final position. So, as you can see from the graph here, x naught is equal to 0, y naught is negative 0.005 meter, xf is 0.02 meter, which is the total length of this electric field, and yf is 0. Now for the first part we have to find the electric field. So for that we need to find the acceleration, and in order to find the acceleration we need to find the time at which it reaches the end of the plates. So basically we know that electric field is equal to force over charge, and force by Newton's law is mass times acceleration over charge. And once we know the acceleration we can calculate the electric field. So let's use kinematic equations to find the acceleration. So first we need to calculate the time. So this is the equation that we will be using. So this is the time taken by the electron in order to travel this distance. Now since there is no acceleration in the horizontal direction, this is equal to 0 because ax is 0, and acceleration is in vertical direction is gravity, which is 9.8 meter per second. Negative 98 meter per second because gravity points downward. Also, the projectile has the following values for velocity. So v naught x is 1.6 times 10 to the power 6 meter per second, and since there is no acceleration in the x direction, the final velocity along x direction, or the component of final velocity along x direction, is the same as the initial one. And v naught y is equal to 0 because there is no initial component of velocity along y direction. Now from this equation we have t to be equal to x minus x naught over v naught x, and substituting these values we get time to be equal to 1.25 times 10 to the power minus 8 seconds. So now we can find the vertical acceleration ay. So remember this is actually may, because the electric field is along y direction. So the force we wanna calculate should be the vertical force, and therefore we need to find the vertical acceleration. So we will use this same kinematic equation but solve it for the vertical direction. So we have y equal to y naught plus v naught yt plus half ay del t square. So in this equation v naught y is 0, so that term goes away, and therefore we have ay to be equal to y minus y naught times 2 over delta t square. Also the final value of y is 0, so this also goes to 0. So finally we have negative twice of y naught over delta t square. So now we can substitute the value of time that we just calculated and the value of initial y and find the acceleration. So that comes out to be equal to 6.4 times 10 to the power 13 meter per second square. So now that we have Ay, we can plug this into this equation where we have the electric field in terms of acceleration. So Ey is equal to MAy over the charge. And here we have already taken into account gravity, or we are ignoring gravity. So we will find that in the last part. So this value of gravity, we are not considering gravity here. So we solve this equation and find the electric field to be 364 Newton per Coulomb. So now in the second part, since we know the electric field, we can find the acceleration of the proton using the mass of the proton, which is 1.67 times 10 to the power minus 27 kg. So we will use this same equation. So electric field is equal to Ma over charge of the proton, and in this case xf is unknown. X naught is as usual 0, y naught is 0.005 meter, and yf is 0 as well. V naught x is vfx because there is no acceleration in the horizontal direction. So now we can solve this equation for A. So that is equal to EQ naught over M, and solving and substituting these values from the first part for the electric field, we get acceleration to be equal to 3.49 times 10 to the power 10 meter per second. So this is the acceleration for a proton. Now if SXF is greater than 0.02 meter, then it does not hit the plane. It does not hit the plate. So let's find the time when the final value of y goes to 0. So we will use the same equation that we used before, solve it for the vertical direction. So here y is 0 because final value of y is equal to 0, and then v naught y is 0, which gives time to be equal to negative y naught over a root over. Now since y naught is negative, time will come out to be real, and this, solving this, we get time to be equal to 5.35 times 10 to the power minus 7 seconds. And acceleration, while substituting the acceleration, we need to put negative sign for the acceleration because it points downward. As electric field is downward, therefore acceleration points downward as well. So while plugging this value, we need to put a minus sign before that. So now we find xf at this time. Now acceleration in the horizontal direction is 0, so the last term goes to 0. Also x naught is 0. So this gives xf to be v naught x times t, and plugging the values of these two, we get the answer to be 0.856 meter. And this value is greater than 0.02 meter, which means that proton does not hit the plate. So now we need to find the time at which xf is equal to 0.02 meter so that it hits the plate. So we will use the same equation that we used before, and these two terms go to 0, which gives time to be equal to x over v naught x, and here x is actually the final value of x, and we get the time to be 1.25 times 10 to the power minus 8 seconds. Now let's find y at this time. And this will give y to be equal to 0.004997. Remember to put a negative sign for acceleration because it points downward, and also use a negative sign for y naught as well. So now that we have y, or the final value of y, we can find the displacement of the proton, which is equal to yf minus y naught, and y naught is equal to 0.005 meter. So we substitute both the values, and this value comes out to be negative 2.73 times 10 to the power minus 6 meter. And here we just need the magnitudes to be plugged into, so don't worry about the direction here. Now for the last part, the electron travels against the direction of the electric field with a greater acceleration, and the path of the electron, if these two are the plates, this one is the positive plate, this is the negative plate, so the path of the electron tends to go toward the positive plate because of the negative sign, negative value of the charge of the electron. And for the proton, the path of the proton goes like this towards the negative plate, and therefore the proton travels in the direction of the electric field with a smaller acceleration because it has a greater mass. And for the last part, whether or not to ignore the effects of gravity, you can ignore the effects of gravity on each particle because the acceleration of gravity is negligible compared to acceleration of each of the particles caused by electric force. So as we calculated, the acceleration for electron came out to be 6.4 times 10 to the power 13 meter per second square, and acceleration of proton came out to be 3.49 times 10 to the power 10 meter per second. And these two values are very, very greater than acceleration due to gravity. So we can ignore the effects of gravity on each particle over here. Thank you.